This is the Capybara group's capstone presentation for the Capybara campus crawl.
Hi everybody, I'm Michael Navjela. I worked on the back end and the API first designed to connect the back end to the front end.
Hello, my name's Alex Santorbi and I worked on the front end.
I'm Daniel and I worked on the back end.
Hi, I'm Isaac Malarski and I worked on the IoT and biometrics.
Hey, I'm Olivia and I worked on the front end.
Hi, I'm Robert. I worked on the actual routing of the program and sort of it's connected to the back end. So our actual project description is a web application to find buildings and routes on Mizzou's campus, sort of like Google Maps, but the key feature is that you can route indoors and through buildings. So one of the main points is that we wanted to cut through buildings during cold weather or any other reasons you wanted to stay inside. And we also wanted to avoid congested areas and traffic. Like, let's say the student center is really busy right around noon, you would route around that. And we also wanted to be able to make stops on the way. So this is our website. You can, let's say, you can add a start and end location, and there's other tabs that we're going to explain later. So if we want to go from the Alumni Center to the Black Culture Center, we can hit submit, drag the interactive map, and we see that it's going from the Alumni Center to the Black Culture Center. And there's this add constraints button that we can prefer indoors. And you see that now it goes through the student center and stops by Strickland. And then if you want to go indoors but also want to avoid crowds, you can mix and match. So it'll still take that indoors route sort of halfway, but then it'll route around the student center, like I said, if it's super busy. And then if we wanted to add a stop, let's say at the Heineckel building, which is off campus, really north, we'll submit it and you'll see that it goes from the Alumni Center all the way up here. And it's still preferring indoors, as you see it's going through Laffrey. So if we uncheck prefer indoors, it'll do a more normal route around the quad and how people normally would walk. And then if you are hungry, you can stop for food and it will take you down up here. And then on your way back from the Heineckel building, you see this little jut there. It stops you by Sabai and then takes you to the Black Culture Center. And then the second route that I'm going to do is from Naka Hall to Anheuser-Busch. It's a pretty simple route, but we can show how things can get more intricate. If we want to add a stop at Ellis Library, you see that it's stopping there and then just going right by Anheuser-Busch. Let's say you are a freshman and you forgot your notebook at Center Hall. You can click that and it takes you to the library, and then you drop your books off, grab your next notebook at Center Hall, and then takes you all the way back to Anheuser-Busch. And just like previous, we can prefer indoors and it changes the route. Instead of going around the library, it takes you through the library. And then Michael is going to talk about two other tabs.
All right. So in addition to creating routes, we're able to also view places of interest. So for example, if you want to look for specific classrooms, you can click on the classroom for the place type and it'll show markers for classrooms. You can also do the same for dining areas, such as Sabai and Gillette. And then you can also do that for study areas, such as Student Center and this dormitory over here. In addition to that, you can also view which devices are collecting crowd metrics on the map as well. As you can see, we have the majority of our data pulled together from the Student Center.
And finally, if you want to find a certain building, you can do that in the search building tabs. So say you want to visit your friend who lives in North Hall. So North Hall is right here. Click submit, and on the map, it should show you where it's located.
And now Isaac is going to talk about his Raspberry Pi.
All right. I was in charge of the IoT and the design of the Raspberry Pi prototype. I designed the scripts and the install for getting it to work on a Raspberry Pi. For this demonstration, I'm going to use it. I'm going to get it to work on my laptop. Generally, like any Linux machine, this will work on, but figure this will just be easier. But yeah, I already have my monitor mode of my access point device in monitor mode. As you can see here, it's classified as radio tab. But if I wanted to automatically get that in monitor mode, I could just run this install script that automatically like installs all the Python requirements, installs aircrack, which is a dependency. Yeah, and basically copies all your environment variables so the database connection is easy. But yeah, for the demonstration, basically what the script does is it calls air dump ng and dumps it into a CSV, which is then analyzed and sent to the database. And the output of that looks like this. Although you have to substitute the device name. Oops. Yeah. And the CSV is kind of formatted weird. The clients are down here and the access points are up here. So it's finding a lot of routers, but the actual number of direct phones that it's detecting is not that many, which is unsurprising. I'm doing this just at my house. So it's like detecting some neighbors, but yeah, other than that, not many people. But yeah, and the CSV looks like this. And that's basically just analyzed via this Python script and sent back to the database. All
right. That is our presentation. Thank you for listening.